Alright, so problems 1 through 6 are very similar. As you go through the work, you're going to see the setup is pretty much the same. So let's take a look at number 1. Whenever you have two angles, the first thing you do is find the third angle. So if you notice on 1 through 6, that's the first thing I did. I found the missing angle. And so you add these two, subtract from 180, and so I got 98. And then I set up the law of sines right here. We were missing B and C, and I color coded it so that, and I try to keep it consistent so it's easy to follow. So you cross multiply, and this line right here would be the equation you get right here. So you divide by this on both sides so that you could leave B by itself. Input this in the calculator and you get this. Do the same thing for C. So I just rewrote it because the ratio I'm using is this one, and I need to find this one, so I just wrote them close to each other like this, so it's easy to see the cross multiply. So it's exactly the same, 16 sine 98, 16 sine 98, C sine 32, C sine 32. Divide by sine 32 on both sides, and then put this in the calculator, you get this. Number 2, same thing. You find the missing angle first. Once you have it, you set up your law of sines right here, and then cross multiply to find the first side that you're missing, in this case B, and then input this into the calculator and you get this. Again, I rewrote it because they're not next to each other, so I have them right here. Cross multiply, divide by sine 38 on both sides, and you get this in the calculator. Number 3, find the missing angle. This time it's angle A. And then this time I set the law of sines over here on this side. Okay, we're missing B and C because they gave you A. So you cross multiply to find B. So here's the line that you get, the equation that you get when you cross multiply. So then I divide by sine 66 to leave B by itself. And put this into a calculator and you get this. Again, I rewrote the other proportion to put them next to each other. So here it is. Okay, cross multiply. And then you divide by sine 66 to leave C by itself. Put this into a calculator and you get this. Okay, number 4, you solve for the missing angle. So 1 through 6 are pretty much identical. It's just different numbers, but the procedure is exactly the same. And you're missing one angle and two sides, okay, for all of them. So I found angle A right here. You add these two, subtract from 180. You set up the law of sines with all the angles already included right here. Cross multiply and then divide by sine 40 so that B is by itself. Input this into the calculator and this is your answer. Okay. Again, same thing, I rewrote this because of the proportion so that they were next to each other, and you see it right here. Cross multiply and you get this line right here after you do the cross multiplication. Divide by sine 40 on both sides and you get this for, after you input this into a calculator, you get that for C. Okay, number 5 and 6 are a little different in that the angles are now with minutes. So all you guys have to do is remember, well, one option is to convert them to decimal degrees and use them as decimal. But at the end, remember, like I showed you right here, the calculator gave me the decimal, but then I converted it to degree minutes because this is how you should give the angle when you input it. And right here, you could put it in decimals too if you like. Okay, I kept it in degree minutes, and just remember, this is the key on the Casio that converts it, but you guys know your own calculator, so you should know how to use the keys on your own calculator, okay, to get the answer. So, but the setup is exactly the same. I found the missing angle first, so here it is. I set up the law of sines, and then cross multiply. Here it got a little bit messier because I didn't have to rewrite the proportions since the value that I have is in the middle. So I did the green one first to find A, and here's the equation. Divide by sine 4530 on both sides, and you get this for A. And then I changed colors and I found this value of C. by doing cross multiplication here, and here's that equation right here on the numerator. Divide by sine 4530 so you could leave c by itself, and this is what you get in the calculator. So remember, this is the key that you have to be pressing after, like for example right here, 74 in this key and then 15 in this key. Or, like I said earlier, you can convert them to decimals and use them as decimals throughout all your calculations, and just make sure that when you're giving the angle, you switch it back to degree and minutes. Okay? Number 6, just like number 5, I found the missing angle. Okay, I got it first in decimal degrees, then I converted it to degree minutes, and the missing, the given side is B, so it's in the middle here, and I can cross multiply and get A, cross multiply and get C. Okay, move it a little bit so you can see the whole problem there. And that's it for 1 through 6. So anytime they give you guys two angles, it's the law of sines, and whether it's side angle, or angle, side angle, doesn't matter. Notice the 6 that I have here, I solved them in exactly the same way. Alright, so number 7 is the ambiguous case, because you have only one angle and you do have opposite sides. So this is the ambiguous case. I checked, let's see, because this side is longer than this side, it's one triangle. So I set up the law of sines here to find angle B right here. And you cross multiply, you get this line right here, you divide by 51.2. And so when you put this into the calculator, you get this decimal. You do inverse cosine of this answer, or like I tell you in class, of the answer. You get this as your angle for B. Okay, so now since you have B and you were given A, we could find C. That's the next one that we find. So here's angle C. After that, you set up another proportion using the law of sines to find C. And so here it is. Notice I used the ones that were given to me at the beginning, these two. I used them again. And then I set up this proportion. You cross multiply. You get this line right here. And then you're going to divide by sine 75 on both sides. Okay. Put this into your calculator and you get C equals 4824. And those are the 3 missing pieces. Number 8, again another ambiguous case. Because this one is shorter than this one, we had a test for H, and here's H right here. I got 2.588. Now since this side is bigger than H but smaller than 10, then that gives me 2 triangles. Okay, when this measurement is between this one, and this is an acute angle, then this is 2 triangles. So I've set it up right here for the 2 triangles. So I'm going to set up the law of sines to find B1. So here's the work for B1. Here's the proportion, and then you solve for B by cross multiplying here. This is the equation you get, divide by 5, and then you put this into the calculator. That gives you the decimal for the sine of B. To find B, you do inverse sine of this number, and you get this angle right here. Now B2 and B1 are supplementary, so we're going to set that up. Okay, so here's the rest of number 8. After finding B2, which is the supplement of B1, right here, that's for the second triangle, I went ahead and I found C1. So how you do that is you take the given angle 15 and B1, add them together, subtract from 180, and that gives you that C1. I did the same thing for C2. I took the given angle and B2, added them together, subtracted from 180, and I got 16.17 degrees. After that, all that's left is the side C's, right? The one for the larger triangle and the one for the small triangle. So here's the setup for the first triangle. I noticed I used the ratio for the measurements that were given to me right here, to the lowercase a and the angle A, and then I set up the proportion, cross multiply, and so when you divide to leave C by itself, this is what you get. and then this is what the decimal that you get. For side 2, I'm running out of room, so I skipped this step. So I set it up the proportion, cross multiply. So to leave c by itself, you have to divide by sine 15. So it's 5 times sine 16.17 divided by sine 15, and you get this. And that's it. Alright, so number 9 is just like number 8. We came up with two triangles, and then we found angle A1, this one right here, and by setting up the proportion, and then we got a ratio. We did inverse sine of this number and got this. For A2, we got the supplement of this angle for A2 right here, and then I found angle C1, this one right here, by taking the given angle plus A1 and subtracting it from 180, and you get this. Same thing for C2, I got the given angle plus the angle A2 right here. So you see them right here. Subtract that from 180 and I got this. Okay, now side C1 and C2. This one here is a setup for C1 and this is a setup for C2. Notice how I use 4 over sine 25 for both of them because that was the given, those were the given measurements. And then cross multiply, divide by sine 25, and I got this. Cross multiply, divide by sine 25 to leave C2 by itself, and I got this. Alright, so number 10, you have an obtuse angle, and because this is shorter than this, it doesn't reach the third side, so there is no triangle. So 11 through 14 are all side angle side triangles, and they want the area. Okay, so here's a setup for each one. They're all set up the same way. The two sides multiplied by a half by the sine of the angle, the included angle. And again, the setup is all the same for them. It's just punching in the numbers in your calculator. Okay, but the setup is identical. There's nothing, there's no ambiguity. It's pretty straightforward. Alright, so 15, I made a mistake in class where I told you guys that this was 75. I didn't look at the problem carefully enough. The typesetting was wrong, but it should have been placed here instead of up in the air. So that was my mistake of telling you guys that it was here. It should be here. So with that in mind, you're looking for the height of the tree. So you're looking for x. So I know because this is a 45-degree angle, I know that this is an isosceles right triangle. So side A equals B plus x. So once we find A and once we find B, we'll be able to get x by doing A minus B. Okay, so first I found B by looking at the small triangle right here and looking for this, given that the hypotenuse is 75. So that would be sine of 20. So this is just SOHCAHTOA. Sine of 28 is opposite over hypotenuse, and you get this. And then for A, it's cosine. So cosine of 28 is A over hypotenuse. So the work is right here, and you get 66.22. You subtract this from this, A minus B, and you get 31.01 feet. Okay. For number 16, this one did not have a